So here's an example of an exam question. I've basically taken out the key points. You're looking for a centre of enlargement in your scale factor. So your centre of enlargement is 0, 1. So the first thing we need to do is plot that. So 0 on the x-axis and 1 on the y, and that's our centre of enlargement. Now, it's really important that you can plot points accurately, because obviously if you were to put it here, which would actually be 1, 0, you'd end up reflecting your shape in completely the wrong direction. It would be quite a big difference away from where it should be. So what we're going to do is we're going to draw on our lines, and actually I'm going to make this a little bit harder. I'm going to make it a negative. Come on, you can do it. Scale factor of -4, but it doesn't look like a negative because of how the computers put it. Okay, so your scale factor is -1/4. So already we know that we're expecting our shape to end up down here somewhere because it's going to become negative. And because it's 1/4, that means all of my lengths are going to be 1/4, so 1/4 of my shape. So here I've got 1, 2, 3, 4, 5, and 1/4 of that would be 5/4, which is 1.25. So my length that I'm actually going to need in the end is going to be 1 and 2, 1.25, which would be here, because that is exactly 1/4 of the centimetre. Okay, so let's draw on some lines, some ray lines. I'm just going to start with 1 to start off with, and then we'll build it up. So what I'm going to do is I'm going to measure the distance between my point here and my point here. So I'm going from my centre of enlargement to my point A, and that's 6.71. So now on my calculator I'm going to divide 6.71 by 4, and that's going to give me 1.6775. So I'm expecting a distance of 1.775. So let's create that from here. So it's 1.6775. So this is exactly 1/4 of the normal distance between here and here. So I'm just going to try and get it to move. Come on, you can do this. There we go. Okay, so line them up. So what you would do is, obviously they wouldn't give you such a hard example, but you would divide the distance between your centre of enlargement and the point that you want to move by 4, and then you would measure that distance going down your line. So I know now that this is my image of A. Come on, you can do it. A. Okay. So that point here is where my A is going to sit. Okay, next one, repeated system. Okay, let's draw a line from one point to the other. So this one was originally called point C, was it? Let's have a look, I think so. Yeah, show label, there we go. So now let's measure the distance between D and C, and that's 7.21. So now we're going to find 1/4 of 7.21, and that's going to give us 1.8025. So now we're interested in this line, so I'm just going to give it a different colour to make it stand out. So I'm going to travel 1/4 of this distance down here, and that's going to be my image of C. So I need to create a line length of 1.8025 centimetres. And then I'm going to make sure that I attach it to the correct ray line, which is there, and now I'm going to label that the image of C. So A and C do actually connect. So what I can do now is just join those two up if I want to. So this line is now completely done. Now we've got two of the points, now we just need our third. So let's create another line from our centre of enlargement to B, and we're going to measure the distance between our centre of enlargement and B, which gave us 10. So a quarter of 10 is going to be 2.25. No, sorry, 2.5, what am I saying? So now we need to create a line length from D with a line length of 2.5. There's my marbles. Okay. So, and it's going to go down this line and it's 2.5. So again, you can use colour in your exam in the sense that although you're only meant to write in black, you can use highlighter or something to highlight a line to be able to keep track of it. So I suggest you do take some coloured pencils or some coloured highlighters into your exam to help you so that you can keep track of your workings. So what we did is we measured this line between B and D, worked out that it was at 10 centimetres. We divided that by 4 because our scale factor is a quarter, and then because it's negative we need to make sure that it's going the other way along the line, so it's going away from our shape past our centre of enlargement. So now I should have, if I just make this colour to make sure I've definitely done it right, let's make it orange or gold. Yep, I've put it on the right line. Let's marry it up a little better. Good. So now I know that I have my image of B, so I should be able to just connect all of my shapes up, and I can colour it in now to show exactly where it sits. Ta-da! And that is a negative quarter of my original enlargement. As easy as that. Now, I was talking earlier about this length here, that I knew that this was going to be the length between A and B. So what I can do now to double check it is move it to see if A and B is that length. And I've completely messed that up because I didn't make it a set line. So let's not look at that. Basically, A and B should be exactly the same distance away from each other, which essentially it is. Now, you might say, oh, you've done it wrong because it's not exactly identical. But again, because GeoGebra has rounded the figures it's using, because I've got quite a difficult one, I'm going to create some error. So that's why really you should never round values between calculations, or it's called technically rounding intermediate steps, because you're rounding a number before you've got to the end of your calculation. Because GeoGebra has automatically rounded the numbers, it hasn't given me the full ones, and also because in your exam you'll only be working in millimetres, you can't have it really, really accurate to a nanometer or a micrometer. You just have to work with what you're given. So I would still get the marks for this because although my line length is not completely exact, it is within the given amount due to rounding. And that's it, job done.